increase in anthropogenic activities and urban development has led to environmental threats, particularly to water resources. Laundry services are one of the contributors to this rise in anthropogenic activity. The surfactant and phosphate content in this wastewater causes various adverse effects, such as a drastic decrease in dissolved oxygen level, leading to the death of aquatic biota, turbidity that inhibits photosynthesis, and alga blooms that damage the ecosystem. Therefore, to address the issue, a combined solution can be applied, integrating phytoremediation, which utilities plan to absorb and accumulate pollutants, with biodegradation, where bacteria naturally break down harmful detergent compounds into safer substances.
In the first stage, the reactor is made by arranging the paper rocks into buckets based on the large rock first. And voila, this is the reactor. Then, the detergent waste as an inlet will flow into the reactor. And from the reactor, will produce an outlet that will be accommodated in a basin. And this is an example of its application.
Now we will discuss about the utilization of microorganisms in biodegradation of synthetic detergents. As shown in the pictures, the surfactant susceptibility to biodegradation are affected by several properties such as microbial properties, environmental properties, and surfactant properties. Such as in microbial properties is gene regulation. In environment properties, there are electron acceptors such as oxygens and also nutrients, temperature, salinity, and pH. And then in surfactant properties, there are affecting of toxicity and the physical states of the surfactants. And this is the visualizations of the bioreactor in which the microorganisms live and creating the biofilm to degrade the surfactant content of the laundry wastewater. In this bioreactor, several genera of bacteria known for the detergent degrading appear to be in the form of consortium, with the interaction of quorum sensing to each other. Like, oh, there are a surfactant there, let's eat together and create some community together so that we could eat and degrade the surfactant together. Oh, okay, sure. I will be sending another signal to other bacteria so that we could create a community each other to degrade the surfactant content of the laundry wastewater. So in the end, they produce some kind of enzyme that could degrade the surfactant content of the laundry wastewater. Several enzymes they produce then catalyze the organic matters of the surfactant in the laundry wastewater so that they could eat those organic matters into carbon dioxide, ammonia, water, and energy, which is fewer toxic compared to the surfactant content before the biodegradation. For more specific reaction, let's take LAS or lineal alkyl benzene sulfonate undergo omega oxidation, which is turn methyl group into carboxylic acid, which catalyzed by monooxygenase and dehydrogenase. Then the carboxylic acid enter a reaction of beta oxidation, where the two carbon fragments enter 3-carboxylic acid cycle as acetyl coenzyme A. Bacteria needs time to degrade the surfactant content, which is represented as the retention time that needed for the bacteria to degrade the surfactant. The calculation of this retention time is 24 hours multiplied by volume of the aeration tank divided by the influent flow rate of the wastewater.
What is this biosand filter? According to Result 2024, the biosand filter is a household-scale water treatment system that uses sand and gravel to support biofilm growth, which helps degrade pathogens and improve water quality by enhancing carbon, nitrogen, and phosphorus content. Filters may be constructed from concrete, plastic, or glass, and when combined with silica, sand, zeolite, and activated carbon are effective in reducing BOD and wastewater. The media components in a biosand filter are vetiver plant, calcoped, silica sand, zeolite, and activated carbon. So, according to Result 2024, the vetiver plant can reduce laundry wastewater pollution through filter remediation. Its roots and root system absorb pollutants such as BOD, GOD, TDS, and turbidity, while also improving water quality by stabilizing pH and increasing dissolved oxygen levels. And then cocopet functions as a biological and physical medium that supports the growth of microorganisms to break down BOD and GOD as well as absorb TDS. However, due to its high air retention capacity and tanning content, it needs to be soaked beforehand to avoid inhibiting microbial growth and increasing BOD and GOD levels. Silica sand function to filter suspended particles, reduce turbidity and odor, and has strong physical properties. Meanwhile, zeolite acts as a support medium that filters coarse particles and absorbs detergent, thereby reducing GOD, TDS, color, and pH. Activated carbon is effective in absorbing complex organic compounds and hazardous pollutants including heavy metals, and can also reduce phosphate levels. The combination of these media enables the biosand filter to treat laundry wastewater through physical, chemical, and biological processes.
The biosand filter and filter remediation methods show significant results with vetiver crest, reducing COD by 98.98% and BOD5 by 88.72%. Other reductions were also seen in parameters such as TDS, conductivity, turbidity, all exceeding 70% efficiency. BOD reduction in biosand filter occurs through two main mechanisms: microbial absorption and biodegradation, and filtration by silica sand and activated carbon. The media also plays a role in adsorption and ion exchange, simultaneously reducing pollutants. The effectiveness of this biosand filter is supported by other studies that show high efficiency in a reduction of BOD with water hygiene and COD with activated carbon reduction of 93.26%. In TDS reduction, cocopit media acts as planting or filter media and structural support, but also provides a habitat for microbial colonies so that it can help absorb solid, including salt ions, which contribute to the reduction of wastewater conductivity. However, it should be noted that the use of organic materials such as cocopit can increase the organic load and the increase in TSS caused by the decomposition process of organic materials. The biosand filter effectively reduces COD by 67.5%, even more than 80%, with the addition of activated carbon. Increasing the thickness of silica sand also contributes to the COD reduction as it prolongs contact with microorganisms.
And yup, a laundry wastewater treatment system that integrates biosand filtration and filter remediation has proven to be highly efficient. The biosand filtration uses activated carbon, zeolite, and sand as filter media, while filter remediation is conducted with vetiver crest or Vetiveria cisanioides, and this combined method successfully and significantly reduce major pollutants, including COD, by up to 98.98%, BOD, turbidity, and TDS. This success is achieved through the synergetic action of detergent degradation by microbes, such as Bacillus, Enterobacter, and Acinetobacter bacteria, and uptake by plant roots. This system shows great potential as a cost-effective, environmental friendly, and effective solution for small-scale laundry wastewater treatment.